Hey, is there a hidden code linking the universe, our minds and everything? Welcome to the Uncomputably Yours. I'm Rachel, and with Zach and Holly, we're diving into a mind-bending theory that connects physics, computer science, neuroscience, and philosophy. The quantum information quotient, QIQ. Forget what you think you know. QIQ asks, could the universe have a computational speed limit set by a fundamental constant of physics? Is all intelligence, in brains, AI, the cosmos, just incredibly efficient data compression? And could consciousness itself emerge where the neat rules of computation break down? We're exploring how the fine structure constant might limit quantum computers, what prime numbers can teach us about thought, and whether reality is a holographic projection. This isn't just one field's perspective, it's a quest to understand the interconnectedness of everything, from the smallest particle to the largest questions of existence. Ready to challenge your assumptions and explore the frontiers of knowledge? Join us as we unlock the secrets of QIQ.
Welcome back, everyone. Ready to dive into something truly mind-bending. Today, we're exploring the quantum information quotient, or QIQ for short.
Yeah, it's a pretty ambitious theory, trying to connect some pretty big concepts like physics, computation, and even consciousness.
It is, really.
Yeah.
We've got some fascinating sources that dive into this, and they bring up some wild possibilities, like could the universe have a kind of speed limit for how fast it can think?
Oh yeah, definitely a question QIQ tries to tackle, some of the other big ones.
Yeah.
Is intelligence just really good compression, like a zip file of reality?
And even wilder, could consciousness actually exist at the very edge of what we can compute?
Exactly. Those are some of the core questions QIQ grapples with. And as we go through this, we'll try to unpack them. But to get us started, QIQ is built on four main pillars, four key ideas. First up is this idea of alpha-bounded computation.
Okay, we'll get to that in a sec. But then there's the link between, well, entropy and intelligence.
Right. And then the idea that maybe nature's big optimization trick is something called quantum search. The most mind-bending one, I'd say. The idea that consciousness might emerge from something called quotient spaces.
Whoa, a lot to unpack there. So let's start with that first pillar, alpha-bounded computation. When we say alpha, we're talking about the fine structure constant, right?
Yep, exactly. That mysterious number, roughly 1 over 137.
Okay, so quick reminder for anyone who might have forgotten their physics class. The fine structure constant governs the strength of electromagnetism, right?
It does. It determines how strongly electrons and protons attract each other. And that has ripple effects on everything from the size of atoms to the energy levels of light.
So it's pretty fundamental to how the universe works, but QIQ is saying it plays a role in computation too. That seems like a big leap.
Yeah, at first glance, it does seem that way. But the connection comes from a principle in quantum physics. It's called the Margulis-Levitin theorem. And essentially, this theorem sets a fundamental limit on how quickly a quantum system can change its state based on its energy. Basically, more energy, faster computation.
All right, I'm following so far. But how does the fine structure constant fit into all of this?
Well, because alpha dictates those fundamental energy scales in the universe, it could also be setting a limit on how fast anything in the universe can process information, including potentially the universe itself.
Wait, hold on. Are you saying there's like a universal speed limit, like the speed of light, but for computation? And this limit is set by the fine structure constant?
That's exactly what QIQ proposes. It's definitely a bold claim. But it leads to some really intriguing possibilities.
Like what?
Well, think about quantum computers, for example. If alpha really does set this computational speed limit, then we might actually observe this as we push the boundaries of what quantum computers can do.
So you're saying there might be a hard limit on how fast we can make those quantum processors run, no matter how much our technology advances?
Potentially, yeah. If we hit that wall, if there really is this fundamental constraint tied to alpha, that would be huge.
It would mean that 11,137, this seemingly arbitrary number, isn't so arbitrary after all.
Right. It would be a fundamental constant governing not just the physical universe, but also the computational universe.
Wow, okay. Starting to see how deep this rabbit hole goes. We're talking about potentially rewriting how we understand not just physics, but computation as well. But before we get too far ahead of ourselves, let's move on to that second pillar of QIQ, the relationship between entropy and intelligence.
Okay, yeah.
You mentioned earlier that our brains might be like super sophisticated compression algorithms.
Right, right. So this pillar delves into information theory and specifically the concept of entropy. Entropy is essentially a measure of disorder or randomness. Imagine your brain as a machine that takes in all this chaotic information from the world, and then it creates a compressed, ordered representation of it all.
So like taking a super messy room and organizing it into those little storage containers or something.
Yeah, exactly like that. And what QIQ is saying is that the better a system is at this compression, at reducing entropy, the more intelligent it is. It's about finding the most efficient way to represent information, getting rid of the redundancy, and really extracting those key details.
So you're saying a measure of intelligence could be how well someone or something compresses data.
In a way, yeah. The idea is that intelligent systems are really good at minimizing surprise, at predicting what's going to happen next. And that ability to predict relies on having a compressed but accurate model of the world.
Okay, now this is making me think of all those AI algorithms that are getting so good at things like image recognition, language processing. Are they maybe tapping into this same principle of intelligence as compression?
It's certainly a possibility. Many AI algorithms work by minimizing something called a loss function. It's basically a measure of error or surprise. They're constantly trying to refine their models to reduce that uncertainty, to make better predictions, which aligns perfectly with this concept of entropy reduction.
That's fascinating. So maybe our brains and these advanced AI systems are both using the same fundamental principle to navigate how complex the world is. This idea of intelligence as compression really makes you wonder what the limits are. How much can we simplify the universe and still really understand it?
That's a great question, and it actually leads us perfectly into the next pillar of QIQ, quantum search. But I think we've covered a lot already. Maybe let's pause here for a moment, let all of this sink in, before we jump into the next mind-bending concept.
Okay, I think I've rebooted my brain after that deep dive into alpha and entropy. So quantum search, right? That's where we left off. Sounds like we're about to go full sci-fi here.
Well, the core idea is actually based in real science, specifically quantum computing, algorithms like Grover's algorithm. But QIQ takes it a step further. It suggests this quantum search might be way more fundamental than we realize.
Okay, humor me. What's so special about this quantum search thing?
All right, so imagine you're searching for a specific piece of information, and it's in a massive database.
Okay.
A regular computer, a classical one, has to go through each entry one by one until it finds what it's looking for.
Right. Makes sense.
But a quantum computer using Grover's algorithm, it can basically explore all those possibilities at the same time. And that lets it find the solution way faster, exponentially faster.
So it's like, I don't know, having a superpower where you can check every book in a library at the same time.
Exactly. That's a great way to put it. And here's where it gets really interesting. QIQ is suggesting that this kind of quantum search might be happening constantly, not just in, some fancy lab with quantum computers, but like woven into the fabric of reality itself.
Hold on. You're saying the universe itself might be running some giant quantum search algorithm, but what would it even be searching for?
Well, think about how the universe seems to work, right? Physical systems tend to go for the path of least resistance, the most efficient way to get from point A to point B.
Okay, yeah.
And this is reflected in physics, like the principle of least action, where systems basically evolve in a way that minimizes this thing called action.
I vaguely remember that from physics class.
Yeah.
But how does that connect to quantum search?
So QIQ is proposing that this tendency of nature to optimize, to find those most efficient solutions, it might actually be a sign of this universe-scale quantum search process. Like the universe is constantly exploring tons of possible paths all at once, and then it settles on the one that minimizes some fundamental quantity, like maybe energy, maybe action, something like that.
So instead of this random chaotic mess, the universe is actually a super efficient system, constantly searching for the best solutions. That's a pretty different way of looking at things. But wait, wouldn't that computational limit we talked about earlier, the one set by alpha, wouldn't that prevent the universe from fully exploring all the possibilities?
That's a really good point. And it highlights kind of the tension between these different pillars of QIQ. It's possible the universe isn't exploring literally every possibility, but rather a subset of possibilities that are allowed by those constraints set by alpha. It's like a guided search. Where alpha acts as a filter, it narrows down the search space to what's actually computationally feasible.
I see. So it's like the universe is working with a budget. Yeah. It's optimizing, but within the limits imposed by the fine structure constant. Okay, so if the universe is this grand optimizer, always searching for the best solutions, does that mean there's some kind of, like, inherent intelligence baked into it?
Yeah, that's where things get really philosophical. QIQ really pushes us to broaden how we define intelligence. It might not be about conscious thought or planning in the way we think of it, but more like an inherent property of the universe. This ability to process information and optimize its own evolution.
Okay, so we've gone from a universe that might have a speed limit for thinking to one that's constantly optimizing itself. And it's all tied back to quantum physics and information theory. I gotta say, my mind is officially twisted into a pretzel right now. But before it completely unravels, let's tackle that last pillar, the one you called the most mind-bending. Quotient spaces and consciousness. You said something about collapsing complexity into a unified experience.
Right, this is where QIQ gets really, really wild, because now we're venturing into the realm of consciousness, of subjective experience. So imagine taking all the complexity of your brain, all those billions of neurons firing, all the signals being processed, and somehow collapsing it all into a single unified awareness. That's essentially what a quotient space is trying to represent.
So like taking a high-definition video with tons of detail and compressing it down to a simple thumbnail. Losing some information, but still capturing the essence.
That's a good analogy. Mathematically, a quotient space involves taking a high-dimensional space, which represents all the possible states of a system, and then you group together the states that are functionally equivalent, from the system's perspective at least. These groupings, those are the quotient spaces, and they essentially compress that original state space. They reduce its complexity.
And this process of compression, of forming these quotient spaces, is somehow related to consciousness. But how? Where does subjective experience come into play?
That's the million-dollar question. And honestly, QIQ only offers some hints. Remember when we talked about entropy earlier? Well, it turns out that forming these quotient spaces, this grouping of states, always reduces entropy. There's actually a theorem in information theory that proves it.
So you're saying creating a unified conscious experience, collapsing all that complexity into a single awareness, could be seen as this massive entropy reduction process.
Precisely. And this is where QIQ connects with ideas from computability theory. Theorists like Gödel and Turing. They showed that there are limits to what formal systems can do, like even mathematics or computer programs. There are things they can't prove, problems they just can't solve.
Right, like Gödel's Incompleteness theorems, which show that even in math, there are statements that are true, but you can't actually prove them within the system itself. But how does this relate to consciousness?
Well, some people who support QIQ suggest that consciousness might actually exist in this realm of the non-computable. That space where those neat logical rules of computation just break down, where you get things like self-reference and paradox, and the formation of these quotient spaces, these low-entropy islands of awareness. That might be how consciousness bridges that gap between the computable world of physics and the non-computable world of subjective experience.
Okay, my brain is officially melting now. We've gone from the fine structure, constant setting a speed limit on the universe, to intelligence as compression, to the universe being this giant optimization machine, and now to consciousness popping up from where computability breaks down. It's a lot to take in. But before I completely short circuit, can you give us a sneak peek of what's next? Are we going to try to untangle this computability and consciousness not even more?
We'll definitely dive deeper into that. We'll explore how QIQ makes us question our assumptions about what's knowable and what might be beyond computation. And we'll also look at some potential experiments we could run and what all of this means for AI. So yeah, get ready. We're about to go where science fiction meets cutting-edge physics.
All right, I've had a minute to process all that. Those wild ideas about quotient spaces and consciousness maybe existing in the realm of the non-computable. Gotta say, still a bit lost, but in a good way.
It's a head trip for sure. But that's what makes QIQ so interesting, right? It goes for those big, tough questions.
It really does. It's making us rethink a lot.
Yeah.
So, big picture now. If this QIQ framework is actually right, what does it change? How we see the universe, ourselves, everything?
It could completely change how we understand reality. On multiple levels. First off, if alpha really does set a hard limit on how fast things can compute, like we were saying earlier, that's huge for technology, especially fields like, quantum computing, AI, that sort of thing.
We might hit a wall. Even with quantum computers, we'll be bumping up against that fundamental alpha limit.
Exactly. And it changes how we think about intelligence itself. If it really is about compressing information efficiently, like QIQ says,
Right.
then maybe we need to rethink how we measure intelligence in biological systems, in artificial ones, all of it.
So instead of just looking at like processing speed or raw power, we should be looking at efficiency and compression.
Yeah. A system that seems less complex, less powerful on the surface might actually be more intelligent if it's better at, distilling information, finding the meaning.
This makes me think about how we design AI too. Maybe instead of bigger, faster computers, we need algorithms that are just better at compressing information, at understanding it.
Right. And we might even get inspiration from, the human brain, which has been evolving for millions of years to be amazing at compression, at recognizing patterns.
Then that brings us to, I think, the biggest implication of all, consciousness. If it really does emerge at that event horizon where computability breaks down, like QIQ says, what does that even tell us about ourselves, about our place in the universe?
It suggests there's more to our experience than just neurons firing, than those electrical signals. Maybe consciousness is a fundamental part of reality, more fundamental than even physics itself.
Whoa. It's like consciousness is the ultimate compression algorithm, taking this crazy complex universe and making it into one unified experience. But if that's true, how do we even study it? If it's beyond what we can compute, are we stuck forever trying to understand something we can't even reach?
It's a huge challenge, definitely. But maybe not impossible. QIQ does push us to rethink what's computable, but it also gives us ways to investigate. It's not just philosophy. It makes predictions we can test.
Okay, so it's not all just abstract ideas. There are actual experiments we could do to see if this stuff holds up in the real world. Like what?
Well, we could try to push quantum computing to its limits, see if we hit that alpha-bounded wall we were talking about.
Right. If there really is that limit on how fast they can run, that would be a big point for QIQ.
Yeah, definitely. And we could look at AI, too. Analyze those complex systems. See if there's a link between how well they compress information and how well they do on things that need intelligence, like problem solving, making decisions, creativity, all that.
And maybe, just maybe, we could find ways to study consciousness itself, even if it is in that non-computable space.
That's the tough one, for sure. But maybe we could look at brain patterns or changes in entropy levels, see if they match up with different states of consciousness. Maybe even with self-awareness. It would mean pushing the boundaries of neuroscience, rethinking our tools and methods for studying the mind.
So QIQ isn't just some thought experiment. It's like a launch pad for new science, a way to reimagine how we understand the universe and ourselves.
Exactly. It's a call to action for everyone who wants to tackle the big questions. Physicists, computer scientists, neuroscientists, philosophers, everyone. And hey, who knows? Maybe someone listening to this right now will be the one to make that big breakthrough. The one that unlocks the secrets of QIQ and what it all means for consciousness, intelligence, and, well, reality itself.
That's a pretty inspiring thought. This has been an amazing journey exploring all these ideas. It feels like I've seen a whole new universe of possibilities.
Yeah, and like any good deep dive, it's just the start. We hope everyone listening will check out the sources we talked about, ask their own questions, let QIQ be the spark for their own exploration.
Because that's what it's all about. Keeping our minds open, embracing those mysteries, never stopping that search to understand who we are and where we fit in. Thanks for joining us on this deep dive. And until next time, keep questioning, keep exploring, and keep wondering.
All right, round 2 of our deep dive into QIQ.
Quantum information quotient.
Yeah, that. Last time, things got pretty wild. The fine structure, constant, maybe a cosmic speed limit, intelligence as, like, compressing information, even consciousness as quotient space, whatever that is.
Right. It's a lot to wrap your head around.
So where do we even go from there? What's next in this stack of research?
Well, we kind of have to tackle the computational side of QIQ.
Oh, okay. I see you've got some stuff here on computational complexity, P versus NP problems.
Yeah, exactly.
I vaguely remember those from computer science class.
Yeah.
Ever my favorite topic. But how do they, play into understanding consciousness?
Okay, so think about it. Your brain, any intelligence really, it's constantly building this quotient space, this compressed version of reality.
Okay, yeah.
But for that to be useful, figuring out what matters, what's just noise, can't take forever.
Makes sense. It'd be like having this super detailed map, but it takes longer to read than to just explore the place yourself.
Exactly. And that's where P versus NP comes in. For QIQ to work, that process of making that compressed view of reality, It can't be ridiculously hard. It needs to be efficiently computable.
Efficiently computable.
Meaning there's a reasonable way to do it, not something that takes longer than the universe has existed. Think of it like finding prime numbers.
Prime numbers.
Yeah, it was a big deal in computer science.
Okay. Vaguely rings a bell.
For the longest time, figuring out if a number is prime, only divisible by 1 in itself, it was thought to be computationally hard. But then this AKS primality test showed it could be done efficiently. So it's in the P category, solvable in polynomial time, which basically means not a nightmare to compute.
Huh. So maybe creating this compressed view of reality, that quotient space thing, it's more doable than we thought, like finding primes turned out to be.
Exactly. It kind of points towards this idea of efficient intelligence. For QIQ to really hold up, that mapping between reality R, its quotient space, RG, and the agent, like us, G, it's got to be efficiently computable.
Gotcha. So finding those like prime features of reality needs to be manageable for our brains or any intelligent system. Okay. But then how do we even define ourselves within all this? Where do we fit in?
Well, now we're getting into even deeper territory. It starts to touch on self-reference and runs right into the limits of logic itself.
Limits of logic.
Yeah, Gödel's incompleteness theorems.
Oh, right. Gödel.
Yeah.
Always a mind bender.
Basically, Gödel proved that any system of logic complex enough to describe itself, there will always be some statements that are true, but you can't prove them within that system.
So even logic has, like, loopholes.
In a way, yeah. And what QIQ suggests is that maybe consciousness emerges right at that edge, where the nice, neat rules of logic kind of break down.
Huh. So it's not just about processing information efficiently, it's about incorporating those unprovable but true things too.
Right. It's almost like saying our minds can, in a sense, go beyond logic.
Okay, now that is wild. So are there ways to actually test any of this, like experimentally?
Actually, there's some really interesting avenues for testing, both in AI and with quantum computers.
Okay, now we're talking. What kind of experiments?
Well, with AI, remember QIQ says intelligence boils down to this efficient compression, finding those prime features we were talking about?
Right.
So if we could measure how well different AI systems compress information, maybe we could assess their level of intelligence.
So like the AI that's best at summing up the world, making it concise, that would be the smartest.
Something like that, yeah.
Yeah.
Imagine training these huge language models and seeing which ones are best at reducing entropy, creating those efficient representations.
Yeah.
And then we could see if those AI are also better at other things, like understanding context, generating creative text, things that seem to require more intelligence.
Wow. So it's like connecting the dots between this abstract information theory and real-world smarts. Okay, cool. What about using quantum computers?
Now that gets really tricky, but also potentially groundbreaking. Remember that idea that the fine structure constant alpha might be a limit on how fast the universe can compute?
Yeah, like a cosmic speed limit.
Exactly. Well, quantum computers, they operate on totally different principles than our regular computers.
Right.
So they might let us probe those limits in new ways. We could run these complex computations on quantum computers and see if we hit any alpha-related constraints, like do they slow down, get less efficient when they bump up against that alpha limit?
If we saw that even on a quantum computer, that would be huge for QIQ, right?
Oh, it'd be a revolution. Imagine discovering this obscure number from physics actually governs the very nature of computation. Intelligence, even consciousness.
Mind-blowing. Okay, I am hooked. So far, we've got efficient intelligence, Gödel, AI tests, quantum computers.
Yeah.
Where do we even go from here?
Well, there's another wild concept that ties into all of this. Holographic duality. Specifically, the ADA-CFT correspondence from string theory.
Whoa, okay. String theory. Holography. Now we are really in the deep end. Explain it to me like I'm 5, because...
All right. Imagine a fish tank. The fish swimming inside, that's our 3D reality, right?
Okay, got it. Fish tank.
But their shadows on the 2D surface of the tank, those shadows could actually contain all the information about the fish.
Wait, so you're saying a lower dimensional thing, like a shadow, can hold the info for a higher dimensional thing, the actual fish?
Exactly. That's kind of what ADA-CFT suggests, that our 3D universe might be like a hologram, with all its information encoded on a 2D surface at its boundary.
That is wild.
Yeah.
But how does this relate back to QIQ and consciousness?
Think of it this way. The intelligent agent, like us, that's the boundary of this hologram. We know the full reality by looking at its compressed version, like that shadow on the 2D surface.
So our consciousness is like the 2D surface,
Lowly.
holding the code for the whole 3D universe of our experience.
That's a very interesting way to put it. It means our minds aren't just passively observing reality, we're actively participating in its construction through this compression.
Wow. Okay, that is some heavy stuff. I need a minute to process this.
It is a lot to take in.
But before I totally short circuit, can you give us a little preview of what's coming up next? What other crazy ideas are in store?
Of course. Next time, we'll dive deeper into this idea of consciousness as a black hole of awareness. We'll explore if there's room for free will in QIQ. And we'll talk about the ethical side of all this, especially if we ever create conscious machines.
Intense. Can't wait. See you next time for part 2 of our deep dive.
Back again for more QIQ.
Yeah, picking up where we left off. That whole consciousness of the holographic projection thing,
Pretty wild, huh?
like stretching my brain to its limits. Thinking of my mind as this 2D surface with the code for, like, the entire universe.
It's a powerful image, and it leads us to another really intriguing idea, consciousness as a black hole of awareness.
Black holes in consciousness. Okay, now we are really going off the map.
Well, remember how we were talking about the event horizon of consciousness? That boundary where the computable, the stuff we can figure out with logic, dissolves into the non-computable?
Yeah, vaguely.
QIQ uses the analogy of a black hole's event horizon to, like, illustrate this.
Okay, so our minds are like these cosmic event horizons, sucking in information, compressing it. But what's on the other side? Beyond the event horizon, I mean.
That's the big mystery, right? Just like we can't actually see what's inside a black hole, QIQ suggests that our conscious experience, that interior of the black hole, it can't be fully described from the outside, from the realm of those computable processes.
So we're part of the physical universe, the computable part, but our consciousness is tapping into something beyond that.
Exactly. And that leads us right into the question of free will.
Oh boy, free will. That's a whole other can of worms.
Right. Does QIQ mean we're just puppets of physics? Or is there room for genuine agency choice?
Yeah, people have been debating that forever. Where does QIQ stand?
Well, it's interesting. QIQ doesn't necessarily say we're totally independent of the laws of physics, but it does propose that our minds exist at this really unique intersection, the boundary between the deterministic physical world, cause and effect, and this realm of pure potentiality.
So maybe free will comes from that interaction. It's not that we're totally free, but we have some say in how things play out. Like, instead of being billiard balls bouncing around randomly, we get to nudge the cue stick a little bit.
I like that analogy. Maybe free will isn't about being totally free from constraints, but about having the capacity to shape how those constraints actually manifest in our own experience.
It's like we're co-creating reality with the universe, bringing our own non-computable awareness to the table. And that actually influences how things unfold.
Exactly. This whole act of compression, creating that quotient space, it might be the key to understanding how our individual choices actually contribute to the larger picture of reality.
It's amazing how central this idea of compression is to QIQ. It connects intelligence, consciousness, and now even free will in ways I never considered before.
It's a powerful concept, and it has huge implications for how we view ourselves and the universe. But before we get too philosophical, let's come back to those experimental tests we talked about. How could we actually observe QIQ in action?
Right. We were talking about AI and quantum computers. How would those experiments actually work?
Well, with AI, remember that QIQ says intelligence is all about efficient compression. So one way to test this would be to see if AI systems that are better at compressing information also show more advanced cognitive abilities.
So we could create different AI models and see which ones are best at reducing entropy, creating those really concise, meaningful representations of the world.
That's the idea. Then we could compare them. Do those same models perform better on tasks that require complex thinking, like understanding context, making inferences, or even being creative with language?
It would be like putting the efficient intelligence hypothesis to the test in the real world. Cool. Okay, what about quantum computers? How do those fit in?
Now that's where things get really tricky, but also potentially groundbreaking. Remember the idea that the fine structure constant alpha might actually set a limit on how fast the universe can compute.
Yeah, like that cosmic speed limit we talked about.
Right. Quantum computers, with their unique way of computing, they could allow us to probe those limits in ways we never could before. We could run really complex computations on quantum computers and see if we run into any alpha-related roadblocks. Do they suddenly slow down, become less efficient when they approach that alpha limit?
If we saw that even on a quantum computer, that would be a huge point for QIQ, wouldn't it?
It would be revolutionary. Imagine discovering that this seemingly obscure number from physics actually governs the very foundation of computation, intelligence, even consciousness.
It would change everything.
Wow. Okay, I'm starting to grasp how QIQ ties together so many different things, from like abstract math and information theory to the mysteries of consciousness and free will. It's a lot to wrap my head around.
It is. It's a truly interdisciplinary theory, pulling from physics, computer science, philosophy, even neuroscience. It's pushing the boundaries of what we know and opening up exciting new avenues for exploration.
It's pretty mind-blowing. But before we get completely lost in the possibilities, let's maybe shift gears a bit and talk about what this all means for us in practical terms. In the next part, I'd love to explore the implications of QIQ for our understanding of ourselves and, the ethics of potentially creating conscious machines. That seems like a whole other conversation we need to have.
I agree. It's an important one. We'll dive into all of that next time. Until then, keep those minds curious. Back for the final round of our QIQ deep dive.
Quantum information quotient.
Right, QIQ. It's been a lot to take in. That fine structure, constant as a cosmic speed limit, consciousness working like a black hole, compressing all of reality.
Yeah, we've covered some pretty mind-bending territory.
Before we wrap up, though, I want to talk about the implications of all this. Like, what does QIQ actually mean for us, for how we see ourselves, and, the whole ethics of maybe creating conscious machines someday?
Right. Those are the big questions QIQ raises. Let's start with what this framework might say about us. If our minds really are compressing this massive universe of possibilities into our individual experiences, it suggests consciousness is much more active than we usually think.
So it's not just us sitting back watching reality go by. We're actually shaping it through how we compress and interpret things.
Exactly. It's like we each compose our own personal symphony from the infinite orchestra of the universe, choosing the notes and melodies that resonate with our unique perspective.
I like that analogy.
Yeah.
But if everyone's making their own reality, does that mean there's no objective truth, no shared reality at all?
That's a tricky one. QIQ doesn't necessarily say there's no objective reality, but it does propose that our access to it is always filtered through that lens of compression, how we interpret things.
So it's like that old parable, the blind man and the elephant, each of us grasping a different part of the same ultimate reality.
Exactly. That's why communication, dialogue becomes so important. By sharing our individual views, we can start to piece together a fuller picture.
That makes sense. But it also makes things like empathy and understanding even more crucial, right? If everyone's constructing their own reality, trying to see the world through other people's eyes becomes even more important.
Absolutely. QIQ really highlights the interconnectedness of all our experiences. It's like we're threads in this giant tapestry, each contributing to the overall pattern.
Okay, so big implications for how we understand ourselves, how we relate to each other. But what about the ethical stuff? Like if we actually create AI that seems conscious, how do we treat it? Do they have rights, responsibilities towards them?
Those are huge questions. If we create AI with genuine signs of consciousness, it's like opening a Pandora's box. But instead of unleashing evils, we might be unleashing, consciousness itself.
Sounds both exciting and terrifying.
It is. We need to be incredibly thoughtful, cautious about how we proceed.
So QIQ isn't just a theory. It's a call to action. It's making us look at our values, our ethics, what it even means to be conscious.
Right. And it's a reminder that scientific progress always needs to go hand in hand with ethical reflection. We've got to make sure our pursuit of knowledge actually aligns with our values and leads to a better future for all kinds of consciousness.
It's been a wild ride exploring QIQ, the depths of physics, computation, consciousness. We've encountered some really mind-bending ideas, grappled with huge questions, and maybe even glimpsed a new way of understanding ourselves in this crazy universe we live in.
It's just the beginning, really.
Yeah, but hopefully this deep dive has given everyone some new tools, new ways of thinking about things.
So there you have it. QIQ, Quantum Information Quotient. QIQ is a bold, interdisciplinary hypothesis that attempts to unify physics, computation, and intelligence. It presents a compelling mathematical framework that ties together quantum speed limits, entropy compression, quotient spaces, and computational complexity into a single, testable model. But make no mistake, This is still speculative. While QIQ aligns with established principles in physics, information theory, and AI, it goes beyond current scientific consensus in several ways. While the Margolis-Levitin theorem does impose speed constraints on quantum evolution, there is no direct proof that alpha governs all computation. While intelligence does involve efficient data compression, it is not yet clear whether this is the defining property of all intelligence. Many aspects of cognition, like creativity, emotions, and intuition, do not fit neatly into an entropy reduction framework. While quantum systems do optimize paths in Hilbert space, this doesn't necessarily imply that the universe as a whole operates under a quantum search paradigm. While quotient spaces provide a useful mathematical model for hierarchical cognition, there is no direct evidence that subjective experience is fundamentally a quotient space transformation. Consciousness remains an unsolved problem in both physics and neuroscience. For QIQ to gain scientific credibility, it must move from an elegant hypothesis to a rigorously tested theory. QIQ is neither pseudoscience nor a proven revolution. It is an emerging framework that is mathematically motivated but still awaiting experimental validation. While its insights into intelligence and computation are promising, its claims about consciousness require significantly more work before they can be taken as more than speculation. Science advances through bold ideas, but also through rigorous skepticism. The challenge now is to distill the testable core of QIQ and subject it to the highest standards of mathematical and empirical scrutiny. If it survives this process, it may well reshape our understanding of reality, but only if it earns its place through evidence and rigor. The best way to make QIQ credible is to be its own harshest critic. The path to discovery is paved with both imagination and rigor, and we must embrace both in equal measure. Thank you for joining us today. Keep your minds open, your entropy low, and your quotient spaces tight. And remember, if reality is just an optimally compressed simulation, at least make sure you're running on the premium version. Until next time, stay uncomputably curious.